Hi, everyone. I'm Rui Mo, a software engineer. Today, I will briefly introduce Apache Gluten and how it drives continuous innovation in big data analytics. Let's get started. Here is a quick introduction about myself. I'm a co-creator of Gluten and have been contributing since the very beginning. I focus on big data distributed systems, especially high-performance native engines. I'm also an active contributor to several projects. The content of today's introduction mainly includes the four aspects. First is, what is Gluten? Gluten is designed as a middle layer that brings native execution capabilities into JVM-based big data engines such as Spark. Instead of replacing Spark, Gluten focuses on offloading performance-critical SQL workloads to high-performance native engines. This allows us to significantly improve query efficiency while still preserving Spark's ecosystem. In terms of how Gluten works, the core idea is to translate Spark's execution into a form that native engines can understand. When Spark generates a physical plan, Gluten first converts that plan into a substrate representation. This substrate plan is then transformed into the execution plan of a native backend, such as Velox or lakehouse. To enable this process, Gluten provides several key components. We implement a plan conversion layer to handle transformation between Spark, substrate, and native engines. We define clear GenAI interfaces that allow efficient communication between the JVM and native layers. We also manage memory and column data exchange to ensure efficient data sharing across boundaries. At the same time, we fully reuse Spark's distributed control flow, so the overall execution model remains consistent with existing Spark workloads. About benefits, one of the major benefits is performance. By offloading compute-intensive operations to native engines, we can significantly improve CPU efficiency and reduce query latency. Another key advantage is flexibility. Gluten can support multiple native backends and allow users to switch between them depending on workload requirements. "2025 was a very fruitful year for Gluten. We continued strengthening execution capabilities, improving performance and stability. And since the March of 2026, Gluten has become an Apache top-level project. To be specific, we focused on performance improvements and we supported Spark new version. We also expanded data lake support to better integrate with modern table formats and ecosystems. We also advanced the GPU enablement. This slide illustrates how Velox is integrated with Spark through Gluten. On the left, we see the Spark architecture with a driver node and multiple worker nodes, each running executors and tasks. When Spark executes a query, Gluten intercepts the Spark physical plan into a substrate plan, then to a Velox plan. Velox then leverages its internal modules for highly efficient computing. In this integration, our work focuses on three aspects. First is transform Spark's plan into a Velox compatible plan. The second is we use various Velox components such as Planode, data tab, file system connectors, memory management, and function libraries. And we run Velox in single thread mode for the Spark setup. This approach allows Spark to take advantage of the Velox highly efficient execution and achieve better performance. This slide summarizes the work in the integration between Velox and Spark. With strong support from Velox community, the Gluten team has implemented the necessary extensions to make Velox fully compatible with Spark. As of now, Gluten supports more than 30 operators and 260 functions. We can look at the progress across the 5 major categories. Firstly, several Spark required operators have been added or improved. We also made some improvements on the storage and I/O compatibilities. These improvements increase the queries can be offloaded to Velox. And to ensure compatibility with Spark semantics, we added many new functions. These functions cover common analytical and ETL use cases. We also made some performance optimizations. These optimizations accelerate real-world workloads running on Velox. Finally, we addressed some stability issues to ensure production readiness. We also strengthened the Spark further tests to improve reliability. With the strong support from the Velox community, these changes have been merged into Velox. In summary, these enhancements bring Velox Spark integration to a mature and production-ready level, improving functionality, performance, and robustness. This page introduces the main challenges we encountered during the integration of Spark and Velox. The biggest category of challenges comes from the incompatibility between Velox and Spark. For example, Spark supports more legacy file versions and more schema evolution behaviors. To address this, we needed to extend Velox's readers so they could fully cover these Spark-specific behaviors. We also needed to extend existing data tabs and support corresponding readers, writers, functions for Spark. We also met several incompatibility issues during the integration of aggregate, memory management, and SPIO. In addition, we also run into some results inconsistency issues. And with the feedback and collaboration from the Velox community, we have resolved some of them and are in the process of resolving the rest issues. This page introduces how Gluten provides native lakehouse support. Gluten uses a unified design to support different table formats in the data lake. The core idea is to reuse the metadata and access control plane while modifying only the I/O plane and implementing it with a native C++ API. With this approach, we can achieve up to 4 times performance improvement for write-intensive workloads on formats such as Asperg or Delta. Gluten's architecture allows multiple compute engines and catalog services to connect seamlessly to native table formats. These table formats sit on top of a wide range of file formats and ultimately run on a unified storage layer. Overall, this native lakehouse design enables us to reuse the upper layer control plane while significantly improving the I/O performance as a storage layer. This page describes Gluten's adaptive hybrid execution capability using both CPU and GPU. Gluten leverages Spark's stage-level resource adjustment and scheduling. This allows the system to decide whether to execute on the CPU or offload to the GPU at the granularity of each stage. The idea is quite simple. We adaptively offload compute-intensive stages to the GPU based on their estimated cost. And the IO-bound stages remain on the CPU. The chart on the right shows a CPU-bound Spark query where offloading the second stage to the GPU significantly reduced the total runtime. And considering the higher cost of GPU, in our evaluation, this hybrid execution finally achieved a 2.5 cost reduction. And let me introduce an optimization we are currently working on. In Gluten today, each task builds its own hash table after receiving the broadcast data, which results in redundant work and higher CPU overhead. Inspired by the implementation of lakehouse, we propose to build the hash table once per executor and cache it for the reuse across tasks. This optimization helps reduce CPU usage and also prevent the out-of-memory issues when using a larger broadcast thresholds. Next, I will demonstrate the benefits of Gluten in some real customer workloads. Shunfeng is one of the largest express logistics service and solution provider in China, and they have offloaded 16,000 SQL jobs to Gluten, and they have achieved about 50% performance improvement compared to vanilla Spark. This helps them to save about 10,000 more than 10,000 CPU units. And of course, there are still some gaps like some complex data types are not supported and some file formats are not supported, like text. And we are in the process to supporting these cases. There is another case for a real customer of Gluten. They have achieved an average improvement of 70% for the parsing jobs, and they have started to offload the most expensive jobs to Gluten, which helps them to save a large cost. In this customer case, they only offloaded table scan to Velox, and the other operators fall back to the vanilla Spark for execution. So with only the table scan offloaded to native, they can already achieve a 7 times performance improvement after some optimizations. There is another real customer use case. They tried about 13 typical queries and they can achieve up to 13 times speed up compared to Impala. While there are also some issues they found, like a Parquet format issue caused query error, and there are some unsupported data types like timestamp, no time zone tab, which caused the query to fall back to vanilla Spark for execution. And we are working on solving these issues. To summarize, Gluten already delivers strong Spark compatibility and performance, and its community is growing quickly as an Apache top-level project. We've achieved deep integration with Velox across key components and addressed many technical challenges to ensure Spark compatibility. And most importantly, the gluten Velox combination has shown solid performance gains in real production environments. This gives us strong confidence in its future adoption. We have GitHub, we have LinkedIn and Slack and WeChat group. So you are welcome to join us, evaluate gluten, raise issues, submit PRs, and share your ideas. That's all I have for this introduction. I'm glad to answer any questions if there is.
There are. Rui, thank you very much. We have a few questions for you. We'll try to go through them as quickly as we can. And if a question isn't being asked that you would like to see asked, make sure to upvote those in the Q&A section on the left sidebar. Okay, so we're going to start with this one. I'm going to put this on the stage. How does Velox handle custom exec nodes in Spark Plan added via extension points? Question from Eugene.
Currently, we haven't tried customer exe nodes in Velox yet. For some Spark specific plan nodes, what we do is to find the Velox plan nodes. If we can extend it, we just extend the Velox existing plan node to support Spark specific behaviors. If we cannot, we just added a new plan node.
Awesome. Okay, we're moving on to the next one. Thank you, Eugene. As a staff data engineer, what would be the justification for using Gluten over migrating the databases to Spark built platform like Databricks instead of using Gluten?
Oh, yeah. This is a nice question. Yeah. Actually, this is about what's the advantage of gluten. What's the real advantage? Firstly, it is open source. The customer can customize the gluten based on their workloads requirements. And the second is Velox and Gluten are both rapidly developing open source projects. So if there are any optimizations or ideas, that might help both the community and the customer workloads a lot. So it adapts fast to the new technology, to the new ideas. And
awesome. Okay.
Oh, sorry.
No, we're moving on. Next one. We got using GPU or exchanging data between CPU to GPU and vice versa. How does data type conversion being handled? And also, you mentioned the hashing algorithms. How do those behave? If you can shine some light on those. This question from Hari.
Okay. Actually, there are GPU operators in Velox now. Actually, there are two independent parts in Velox. The basic part is for CPU, and the GPU part is new operators, but similar to the existing ones. But the difference is the GPU operators called the libcuDF. So if gluten translates to a GPU operator, the GPU operator in Velox will automatically offload that computing to GPU. So the data type and the operators all need to be supported in the GPU part in Velox.
Awesome. We got another couple here. Thank you, Hari, for this question.
Thank you.
What? Okay, so Hari, I think it might be another one from you. I was looking at Quantum, which is Spark Kubernetes operation, which is more efficient compared to traditional Spark. So do we have benchmark between Quantum and Gluten? And can both be amalgamated to achieve even more performance gains?
We haven't had a benchmark between Quantum with Gluten, but I think it is possible that we can achieve more performance gain with the Spark Kubernetes operation. Yeah, we can take a look at that.
Okay, let's see. I think we might have one more here. Hari, thank you for those. Abhishek, what kind of workloads are not suitable for Gluten? I don't know if it's a trick question. But maybe people are trying to think we can frame it another way. How should people recognize a problem as a good fit for Gluten? When should teams say, you know what, I understand the benefits, but this is right for me, or this is not right for me? Do you have any recommendation?
Actually, Gluten offloads the computing to native, so the CPU bound queries benefit most. So if a query is IO bound, the benefits may be less than those CPU bound queries.
Okay, cool. If you have a more specific, if you'd like to unpack this, Abhishek, then feel free to do that in the chat too. Let's see, maybe we'll squeeze in one more. Okay, this one, because I think we're going to talk about some similar things in a few sessions. I think we're going to have one specifically about UDFs. PySpark suffers a lot for Python UDF due to SIR-D. Oh, man. Do you have a sense how you avoid the expensiveness of this between GPU and SIM versus the tungsten boundary? This is fairly in the weeds. I don't know if you have an answer to this.
I have limited knowledge to the serialize and deserialize process, but I can share how Gluten supports the UDF. It supports a user to write the UDF as a dynamic library and just load it at runtime. So that might be different from the Velox way.
Awesome. Rui, thank you very much for joining us today. Stick around in the chat a bit longer to answer some of the other questions we didn't yet get to. We really appreciate your time and the work that you're doing on Gluten. And thank you very much for coming.
Thank you. Thank you for joining this session.
Thank you. Okay.